Okay, good evening to all. So I am going to take the live session for NPTEL 2024 lecture series for Municipal Solid Waste Management taught by Professor Ajay Kalamdar. So first we will start with the revision of the previous week lectures. Then based on those lectures, we will solve some problems which can help you in solving the present course assignments. Okay, so we will go with the quick revision of previous week lectures. So before that, we have learned about the different types of waste categories, how to treat them, and how to convert them in different valuable assets like composting, or we can turn them into biogases, or how to treat the remaining waste via landfill processing. Okay, and what are the different factors which are used during the landfilling process, and what are the different factors which uh, used for deciding the critical factors or the places to decide a landfill site. Okay, so now we will talk about some special waste categories which we generally do not treat them under municipal solid waste. Okay, so we will talk about the special waste categories, like first one is construction and demolition waste. So there are four different types of construction and demolition waste. First is construction, then we come to demolition, then deconstruction and construction, then coming to construction and demolition waste. So during the construction waste, like process of erecting of building or build facility or other structures or building of infrastructure, including alteration in these entities. So during during the building during the build of new building facility, or we can say if we are going for a renovation in the building, so whatever the waste which is going to created during that renovation process or new building. Okay, so that will be known as the construction waste. Then coming to the demolition waste, when we are going for the complete demolition of a building. Okay, then the waste generated during that process will be considered as a demolition waste. And during the deconstruction, like plant selective demolition, in which we are going to demolish some part of the building and then we are going to recreate it. Okay, so the waste generated during that process will be known as deconstruction waste, and this whole waste is commonly known as the construction and demolition waste. And we already know that this construction and demolition waste cannot be recycled back easily. Okay, so we have to go for the landfilling process only. Okay, but the main thing with the main problem with this construction and demolition waste is higher quantity of that waste. Okay, that waste is going to take very high volume during the landfill processing. Okay, and that requires a huge area of landfill sites. Okay, and we cannot create until if we are or the thing is that we cannot recycle this construction and demolition waste, and if we are also going for the landfilling process, that will not help us to create any biogas from this waste. That will not help us to create any composting from that waste. So that is like very huge problem during this municipal solid waste management. So the major components involved in these waste are like broken bricks, cement plaster, steel material, which is generally used for reinforcing the concrete, and then rubble and stone, timber or wood, especially demolition. If we are going for the demolition of old buildings, in which they were they used high amount of the timber or wood during the building process. Okay, then some of the minor components are also there, like conduits like iron and plastics, pipes, electrical fixtures, panel and glaze tiles. So in this construction and demolition waste, as we can see, we can recycle this steel. Okay, then we can recycle some of this timber or wood. and then these panels or glazed these panels we can recycle if they are made from wooden, or if they are made from plastic or steel. So these things can be recycled. But what about these bricks and cement plaster that cannot be recycled back, because cement plaster cannot be reused as a raw material for making the new cement. Okay, that we have to think about that thing, what we are going to do with that waste. Okay, so these wastes can create huge problems, like construction and demolition waste generally stored outside the construction sites and along roadside are a cause of both traffic congestion and mishaps. Then waste from small generators quite often find its way into the nearest municipal bin. Okay, like if we are talking about the streets, okay, and if we are going for the renovation of our house, okay, so whatever the construction and demolition waste has been generated during that process, what we will do, we will just throw it away in the municipal solid waste bins. Okay, and that waste is going to be create a huge problem during the processing of that municipal solid waste, or it can create the clogging of drains due to the dumping of these waste outside the streets, and that will create the urban flooding during the heavy rainy seasons. So there are the major stakeholders involved in this in the generation of these types of waste are generally service providers, waste generations and local authorities. Then there are some responsibilities of stakeholders uh, for the proper utilization, or we can say proper utilization of these construction and demolition waste, like collection, segregation, storage. Generally in India, around uh, there are two categories, like 200 tons per day or 300 tons per project. Segregate the waste into four streams such as concrete, soil, steel, wood, and plastic. So these steel, wood, and plastics can we easily go for the recycling process. And other waste, we have to think about the other waste what we want to do with these concrete, soil, bricks, and mortar. Then submit waste management plant and get appropriate approvals from the local authority before starting construction or demolition or remodeling work. So we have to take a proper permission from the local authorities before starting any construction and demolition work. Okay, so that they can be prepared for the proper management of so that they can easily manage this type of waste generated during the whole process. Okay, keep waste within premises or get deposited at collection centers made by local body. Hand over to, or we can hand over it to authorized processing facilities, and ensure no littering or deposition to prevent obstruction to traffic or public or drains. And no mixing, like we cannot mix this waste with the other type of municipal solid waste. Okay, so we cannot put this type of waste into the collection bins which has been kept outside of the streets or the societies by the municipal corporation, because it will lead to the mixing of these construction and demolition waste into the wet waste or dry waste, and that will cause major problems during the recycling of the municipal solid waste at the processing sites. Then prepare within 6 months from the date of notification a comprehensive waste management plan covering segregation, storage, collection, reuse, recycling, transportation, and disposal of construction and demolition waste generated within their jurisdiction, and remove all construction and demolition waste and clean area every day. Or if not possible, then we can tie up with the authorized agencies for removal of this construction waste and pay them the relevant charges as notified by the local authority. So in case of for recycling this construction and demolition waste, or the proper disposal of this construction and demolition waste, sometimes we have to pay a proper fees to the local authorities so that they can manage that construction and demolition waste in a proper manner. uh, then there are some other things like processing. So what are the processing steps for construction and demolition waste? So C&D waste can be put to a profitable use, like given the scarcity of sand and stone for construction, thereby saving natural resources. So the sand and gravel, Okay, sand or rubble, or we can say small stones produced during this construction, found in this construction and demolition waste, can be grinded back to make the sand particles, and that sand particles can be mixed with the cement for uh, proper for again reuse, for reusing it again in the building material, as a building material. Then prevents public nuisance and traffic congestion issues arising from indiscriminate dumping of the construction and demolition waste. Then third one is saves valuable space at landfill sites if we are able to properly dispose of this construction and demolition waste, or we can say if we are able to reuse it in build in as a building material. Okay, that will save us valuable space at landfill sites, because if construction and demolition waste is going for the landfill sites, then it will take a huge chunk of that landfill sites, okay, for disposal of that construction and demolition waste only. Then it reduces cost of bulk transportation if recycled close to source of generation. If we are able to recycle it at the at close to the source of generation, then it will reduce the cost of bulk transportation. Then coming to reuse and recycling potentials, like demolition waste, it can be processed, crushed, and sorted, and end use will be the recycle. It can be reused as a recycled aggregate. Okay. Then construction waste, it can be washed to remove cement and recover aggregate. The aggregate can be recovered, and that can be also recycled back in the construction material. Then reinforced concrete waste, it can be processed after crushing and sorted to recycle the steel, for the removal of the steel bars in this reinforced concrete waste, and that steel can be recycled back, and the gravels produced, gravels and smaller dirt particles produced during this whole process can be reused back as a construction material. Then clay bricks and roof tiles, these can be cleaned, crushed, and sorted and pulverized, and the end use will be it can be reused for masonry aggregates mixed with lime to produce mortar. Then calcium silicate bricks can be cleaned, crushed, and sorted, and that can be pulverized back in the powder form, and that can be reused as uh, a raw material for creating the mix, for creating new calcium silicate bricks. Then natural stone masonry, these can be cleaned and crushed, and these after crushing these natural stone masonry, this can be reused back as a masonry or can be reused as a aggregate material. Then aluminium, which can be produced by the angles, and uh, in the new buildings we can see we are going with the doors of aluminium. Okay, so that aluminium can be directly recycled back, and the steel produced during the construction material, that can also be recycled back easily. Then mixed demolition waste, it can be crushed and it can be reused as a filler material during the construction of a new site. Then asphalt paving, ceramic tiles, these are also most of the times whatever the waste we are creating as a construct during the construction and demolitions, that can be crushed and grinded into the powder form, or if it contains some plastic or steel or aluminum type of material, that can be easily recycled back. Otherwise other all things can be crushed and grinded to form fine powders, and that can be reused back as a construction material itself. And then timber or beams can be reused as a fuel source, and then timber boards, these are also can be reused as a fuel source. Then plastic can be easily recycled. Gypsum plaster boards, that can be reused for creating new gypsum product. Then glass, it can be recycled easily. So there are some proposed use of construction and demolition waste, like we are able to easily recycle the plastic, steel, aluminium, and asphalt material produced during these construction and demolition waste. So what are the other proposed process for the recycling of the remaining part of that construction and demolition waste? So demolished concrete blocks can be grinded to finer size, and it can be recycled in the form of fine aggregates. Okay, and these RCAs should be pre-wetted near to SSD like saturated surface dry conditions before used to avoid rapid slumps loss due to its high water absorption rate. Admixtures with better slump retention effect would be useful. So these recycled fine aggregates can be reused back as a construction material for providing the proper absorption of water, or we can say if we want to create a proper water cleaning system, so that these types of waste can be these type of waste can be reused as a absorbent material for creating the uh, water purifying systems. Okay, then there are some other proposed use of these. So there are some quality standards which we have to maintain during the creation of construction and demolition waste, or we can say during the construction and demolition of any new building. We have to keep these factors in mind, or we can say we have to follow these rules, like site clearing should be done, so potential issues like dust and noise should be avoided, and it can, if we are not going for the site clearing, okay, that can impact the health, and it can create air pollution, ambience or visual impact, and flora and fauna habitat will be affected due to these things. So there are some other factors also which we have to keep in mind during the construction of any new building or the demolition of the old buildings. Then these are like nothing. Okay. Okay, then coming to the second special waste category, which is related to the biomedical e-waste and inert waste. Okay, so the management of these waste should be done in a different manner. These cannot be counted under the municipal solid waste. That thing we have already discussed in the previous week lectures, that biomedical waste, e-waste and inert waste in the cannot be counted as a municipal solid waste. Okay, so special waste including domestic hazardous waste like comprising any solid waste or a combination of solid waste that requires special handling and disposal because of its quantity, concentration, physical and chemical characteristic or biological properties, in order to protect human health and environment. These types of waste comes under the special waste category. So these types of waste generally includes the plastic waste, biomedical waste, slaughterhouse waste, electric and electronic waste, which majorly includes the batteries and wires, then waste tires and battery waste material. Special waste including domestic hazardous waste should not enter the municipal solid waste stream. It should be treated in a different manner. Special waste are generated at the household and commercial level, and due to the lack of segregation at source or improper collection system, they frequently end up in the mixed municipal solid waste stream. So, according to the guidelines of the ISWM hierarchy, these waste should be first. We should try to reuse them. Then we can go for recycling process, and waste that cannot be reduced or minimized should be reused and recycled. Then electronic waste can be easily reused or recycled. Then biomedical waste should not be recycled and should be appropriately treated and disposed of to prevent hazardous impacts of undesirable dumping of these waste. These biomedical waste generally contains the sanitary napkins and the diapers, and like we can say the waste generated from the hospitals comes under this biomedical waste category. Then recycling of special waste including domestic hazardous waste provides economic as well as environmental benefits and reduces reliance on virgin materials. Okay. Then coming to the biomedical waste category, biomedical waste is generated during the diagnosis, treatment or immunization of human beings or animals, or research activities pertaining thereto, or in the production or testing biological or in health camps. The biomedical waste shall be disposed of in accordance with the biomedical waste management rules 2016. So we have learned about the municipal solid waste management rule 2016. At the same times, we have also created the biomedical waste management rules 2016. So the any type of biomedical waste generated should be treated according to this biomedical waste management rules 2016. So the rule schedule third of the biomedical waste management 2016 mandates that local authorities such as gram panchayat, municipalities or corporations to provide, they should provide or allocate suitable land for setting up of common biomedical waste treatment facilities in their respective jurisdiction as per the guidelines of CPCB. So they have to create a proper setup, proper recycling, or we can say proper disposal setup for properly disposing of these biomedical waste. So for households or any institutions which is generating this type of biomedical waste, they should contact that facility for the proper disposal of their biomedical waste. Okay. Site selection authority for common biomedical waste treatment and disposal facility. The department in the business allocation of land assignment shall be responsible for providing suitable site for setting up of common biomedical waste. So there are some rules of these bio. So the typical household biomedical waste generally contains solid sanitary napkins, adult or baby diapers, then blood stained cotton buds, used band-aids, split mercury like thermometers, and injected needles, discarded insulin pens. So these are the some of the house some of the biomedical waste which are generated in the households. And if we are talking about the hospitals, okay, or some research institutions, the types of biomedical waste generated inside those institutions can vary vary according to the different categories. Okay, then segregation and collection of household medical waste includes the biomedical waste generated in household shall be segregated as per the BWM rules 2016, and then these biomedical waste should be handed over in separate bags. Generally, we use yellow type of bin, yellow color of bin having a hazardous biohazard sign on those bins. Okay, for the for keeping these biomedical waste. Okay, then these containers should be hand over to the municipal solid waste collectors in a separate bag. Okay, then ULV shall have tie up with the common BMW treatment and disposal facility to pick up this waste from MRF or from the household directly for final disposal of these biomedical waste. So biomedical waste from healthcare establishment includes like healthcare establishment generally includes hospitals, nursing homes, pathological laboratories, which generate huge amount of biomedical waste as compared to the households. These waste should be segregated at the point of generation and stored in the color coded containers separately following the provision of BWM rules 1998, and that was amended in 2011, then again in 2016. This category of waste is hardly 25 to 30% of the total waste generated by the healthcare facilities. Then biomedical waste should be sent for further treatment and disposal as per BWM rules 2016. This is essential to ensure that MSW generated from healthcare establishment is not contaminated with these biomedical waste. So we have to separately put the MSW in separate bins and biomedical waste in separate bins so that we can hand over it to the concerned facilities for the proper disposal of these different types of waste in proper manner. Then biomedical waste has been classified into four categories as per the rule 2016, and different treatment or disposal systems have been indicated for them. Then these are some existing rules for the treatment of biological waste. Okay, then coming to the second category of special waste, that is e-waste. So e-waste generally contains the electric and electronic waste. So if we are talking about the household, so households are we can say households are not the major producer of these type of waste. Okay, Generally bigger institutions produce a healthy amount of the e-waste, like we can say IT companies or schools, or we can say generally hospitals are also nowadays hospitals are also producing this e-waste. There are different categories of e-waste. One is IT and telecommunication equipment, uh, which includes centralized data processing like mainframes or mini computers, then personal computing devices like personal computer, laptops, and notebook computers or mobile phones. Then printers including cartridges, electrical and electronic typewriters, copying equipment, user terminals and systems. Then there are telecommunication devices like telephones, cordless telephones, cellular telephones, and mobile phones. Then second category is consumer electrical and electronics. These generally includes the television sets, including liquid LCD type display or LED or CRT type display technology. Then refrigerator, refrigerator, washing machines, air conditioners, and excluding centralized air conditioning plants. Uh, those comes under different categories, and fluorescent and other mercury containing labs. These comes under consumer electrical and electronics e-waste category. Then these e-waste generally consist of more than 1,000 types of different components which can be categorized as hazardous and non-hazardous. Generally, these e-waste also contains major amount of the metallic values. So if we are going for the proper processing of these e-waste, we can recover around 50 or 60 types of different elements, different metallic elements from the recycling of these e-waste itself. Typically, e-waste consists of ferrous metals like approx 50%, and plastic, which is also a major part of these e-waste, around 21%. Then non-ferrous metals like which are valuable: copper, aluminium, silver, gold, platinum, palladium, approximately 13%, and other components like glass, which are approx 16% of the total e-waste generation. Then these most plastic components in e-waste include phthalate plasticizers and brominated flame retardants. And if we are going to burn them, okay, then it will create the hazardous bromine gas, and that is very harmful for the environment. Okay, so a proper treatment process has to be done for the disposal of these e-waste constituents. And we cannot go for the landfilling of these e-waste, because during the landfilling process what will happen, these phthalate plasticizers and brominated flame retardants are going to get reacted with the mm, water and acid content generated during the landfilling of these waste, and that will create the contaminations in the groundwater, or that will create major health hazard problems. Then therefore, even though the plastic recovery potential from e-waste can be quantified, presence of above mentioned chemicals limits the actual recycling potential. So the plastic generated from these e-waste cannot be recycled with the plastic generated during the municipal solid waste. Okay, those the plastic generated in the e-waste and the plastic generated from the other sources should be recycled separately. Okay, because the composition of these both plastics are entirely different. Okay, so that things we have to kept in mind during the recycling process. Then there are some important notes. The following one thing is that the batteries used in electrical and electronic equipment, which includes generally nickel, cadmium, or lithium ion or mercury batteries, are not included in the has not been included in the e-waste streams. Uh, the e-waste management rules formed in the 2016. So these types of batteries are not included in the e-waste rule 2016. Then compact fluorescent lamps. There are two methods of recycling these compact fluorescent lamps like CFLs and tube lights. Shredder method and cut method. The shredder method involves crushing of CFLs and chemical treatment of the crushed materials in dust tight containers to avoid spillage of any harmful substance. Generally, these CFLs and tube lights contains harmful mercury inside these tube lights. So if we are going to crush them, so that has to be done in a entirely uh, we can say entirely closed facility, so so that we can avoid the spillage of the harmful mercury content in the environment, because these CFLs and tube lights contain mercury in the vapor form. So when we are going to uh, crush them, okay, so that vapor, the mercury in the vapor form is going to release in the environment, and that is very hazardous for the human health. Then e-waste handling in India, there are two different sectors which are working for the e-waste handling in India. One is formal sectors, then another one is informal sector. So the basic difference between these sectors are, the formal sectors are um, doing the processing, or we can say recycling, of these types of e-waste or disposal of these e-waste with a proper facility and proper rules. According, they are following proper rules which has been described in the e-waste management rules 2016, and it includes facilities authorized to deconstruct electronic having capacity of disposing 5 tons per day. Formal sectors receive e-waste from the producers of service centers or take back schemes or companies that follow the environmental policies on disposing e-waste. The formal sector only follows procedure of dismantling and segregating parts. They do not physically dispose of the e-waste. While the informal sector, they do not follow any rule, okay, they don't have any license for the recycling of these types of e-waste. The informal sectors handle e-waste by recycling or final disposal of these e-waste. So what they are doing, they are just going for the burning of this e-waste, or they are going for the acid treatment of these e-waste, so that they can recover the valuable metal content present inside these e-waste, like copper, aluminium, silver, gold and platinum material. Okay, there is a whole economic market for e-waste, because the parts can be dismantled and the scrap metals can be recycled back for making money. Then some of the methods used by these sectors are acid baths, burning cables and disposing in landfills. They are just collecting the metals by burning the whole plastic material, or by using acid baths, and whatever is remaining behind, okay, after the recovery of the metallic values from these e-waste, they are just going for the landfills. Then methods of e-waste treatment and disposal. There are different methods. First one is incineration methods. It involves combustion of e-waste at high temperature in specially designed incinerators. Okay, because these, during the incineration process, we have already discussed these e-waste generally consist of brominated flame retardant and pla pathogens, plasticizers, okay, so that are going to create major air pollution problem if we are going to burn them in the open. Okay, so we need properly designed incinerators which can treat these off gases, which includes bromine, fluorine and other hazardous components. Okay, so we have to especially design these incinerators for the proper treatment of these e-waste. This e-waste disposal method is quite advantageous as the waste volume is reduced and the energy obtained is also utilized separately. Then, however, it is also not free from disadvantage, with emissions of the harmful gases such as mercury and cadmium in the environment. If we are not going for the proper treatment of the off gases, so mercury and cadmium are going to uh, released in the environment, and that are going to create major health hazard problems. Then another method is acid bath. It involves soaking of the electronic circuits in the powerful sulfuric, hydrochloric or nitric acid solutions that free the metals from the electronic pathways. So what will happen during the acid bath, whatever the metal is present inside those e-waste, okay, that is going to dissolve inside these acids, and the plastic will remain as a residue material. The recovered metal is used in the manufacturing of other products, while the acids are recovered through various acid recovery process, so that we can reuse them for the recycling of fresh e-waste. Then one another method is landfilling. Most common methodology. This is the most common methodology for e-waste disposal. soil is excavated and trenches are made for burying the e-waste in it. An impervious liner is made of clay or plastic with a leachate basin for collection and transferring the e-waste to the treatment plant. However, landfill is not an environmentally sound process like we have already discussed. These types of e-waste also contain some hazardous elements like cadmium, lead, mercury, fluorides, bromine, and that are going to get released inside the soil and groundwater during the landfill process, and that will create major health hazards due to the disposal of these e-waste. Okay, so there are some existing rules for the treatment of e-waste. These rules are based on the principles of extended producer responsibility, wherein the producer engaged in the manufacturing, sale, or purchase of these types of electrical and electronic equipment is responsible for the end of life management of the electrical and electronic products listed in schedule 1 of the rules. So whatever they are selling, okay, they have to create a proper chain. Okay, they have to create a proper management for the recycling of the end products. Okay, whatever we are going to discard it after 4 or 5 years, they have to take it back, or they have to recycle it properly. Okay, that is known as extended producer responsibility. Then producers are provided for handling e-waste as applicable to all stakeholders such as collection centers, dismantlers, and recyclers of e-waste. Stipulations for reducing the hazardous substance in electrical and electronic equipments are also prescribed. Then there are some procedures and format for registration of facilities for recycling e-waste. Uh, these are also specified in these Electronic E-Waste Management Rules 2016. Then third waste is inert waste. That generally includes the street sweepings. Street cleaning is a fundamental service ensuring clean and hygienic urban conditions. And street waste includes paper, plastic, dirt, leaves, and other vegetative matters. So the paper or plastic can be recycled back. Then leaves can be recycled as a compost material. Vegetable matter that can also be recycled as a compost material. But whatever the dust is coming with these sweepings, okay, with these street sweepings, that is generally known as the inert waste material. Manual sweeping is commonly practiced in India as many streets are congested and narrow. Inefficient waste collection system coupled with public littering significantly contribute to waste piles on the street. Then, according to the solid waste management rules 2016, there are some requirements for street cleaning. Like direct street sweepers should not to burn tree leaves collected from street sweeping and store them separately and hand over to the waste collectors or agency authorized by the local body. They have to collect the separately waste from sweepings of street, lanes, and by lanes daily, or an alternate day or twice a week, depending on the density of population, commercial activity, and local situation. Then they have to set up and cover secondary storage facility for temporary storage of street sweeping and slit removed from surface drains in case where direct collection of such waste into transport vehicles is not convenient. Waste so collected shall be disposed of at regular intervals as decided by the local body. Then manual handling of waste is prohibited. However, if unavoidable due to constraints, manual handling should be carried out under proper precautions with due care for health and safety of workers. Workers should be provided with protective gear such as uniform, shoes, gloves, and other implements, etc. for their safe and easy working, and they should be subjected to periodic health checkups and should be provided with social security benefits during health insurance. Then the planning for street cleaning varies for different cities like small towns, medium cities, and mega cities. Like we have to vary the equipment for the planning for street. Then staff requirement will be different. Then there are some terms for uh, street classification and street cleaning frequency. Street sweeping in residential areas may be carried out in two spells like 5 hours in the morning and 3 to 4 hours in the afternoon. So there has to be two shifts for the proper cleaning, for ensuring the proper cleaning of the streets in a city. The staff involved in street sweeping should also be responsible for cleaning drains up to 18 inches depth along the same beat. Multiple handling of waste should be avoided. Local sanitary inspectors should be responsible for inspecting and maintaining records on the extent of service provision. ULVs can adopt different strategies for tourist places where many people are present almost at all hours. In such places, regular cleaning throughout the day, like 2-3 times, and during weekends and national holidays, may be necessary. Then coming to the manual street cleaning involves sweeping and collection of waste by sanitation workers from streets, roads, lanes, bylanes and public places. Then street sweepings normally includes cleaning the road surface and footpaths on both sides of the roads. Then all waste from street sweeping should be transported separately without mixing with domestic or any other commercial establishment waste, because these street sweepings generally contains major part of the inert waste material that cannot be recycled back easily. Okay, so if we are going to mix them with the household waste, so we will be we are we it will create a major problem during the recycling of the whole municipal solid waste. Okay, then types of street cleaning equipments like long handled brooms, or we can go with some shovels, then hand carts, mechanized. There are some mechanized street cleaning equipments, also like mechanical broom sweeper, which is then regenerative air sweeper, vacuum sweeper for the proper cleaning of the streets. Uh, then cleaning of surface drains, slit management is should be there. Like wet slits should be removed from the main roads in less than 4 hours, and in other areas within 24 hours, and should be directly transported to the landfill or be disposed at the waste storage depots. Okay, because these the slit produced during the street cleaning cannot be recycled back easily. Okay, so that has to be directly disposed of at the landfill site itself. Okay, this waste is not amenable for composting given the possibility of high contaminants and inert content in the slit. So that has to be directly disposed of at the landfill site so that it can be easily landfilled. Okay, then integrated solid waste management rules. These are rules which you have to read. There is nothing much about understanding these rules. Then municipal solid waste management rules. Those you have to read and remember them. So, what are the areas of application of these rules, like for where it will be applicable, or on who? On whom it will be applicable? Like it will be applicable on ULV, census towns, industrial townships, areas under Indian Railway, ports, harbors, airport, air bases, central and state-owned organizations like defense sectors, defense establishments, then places of pilgrimages, religious and historical importance. Every domestic, institutional, commercial, and any other non-residential solid waste generator situated in the areas should come under these ISWM rules. So, different waste generations are every household or event organizers, market associations, hotel and restaurants, gated communities, and resident welfare associations. So, in the ISWM rules, there are different rules for the different types of waste generators. Then, for household level, the main rule is that they should segregate the waste at household levels, like they have to segregate the waste in different categories like dry waste, solid waste, and e-waste materials should be segregated differently, and the hazardous waste content, or we can say biomedical waste. So they have to segregate the waste in the different categories, and they have to provide the waste to the waste collectors in the different bags, okay, according to the categories of these waste. Then on the in case of agriculture, uh, in case of household waste, they sell store horticulture waste and garden waste generated from his premises separately and dispose of as per the direction of the local authority, or they can use this type of waste for producing the compost inside their household also. Then at the event organizer level, no person shall organize an event or gathering of more than 100 persons at any unlicensed place without intimating the local authority at least 3 working days in advance. It shall ensure segregation. They shall ensure segregation of waste at source itself, and they should hand over it to the local authority for the proper disposal of the waste produced during any type of event. Then at street vendor level, every street vendor shall keep suitable containers for storage of waste generated during the course of his activity, such as food waste, disposable plates, cups, cans. Like they have to provide different bins. They have to keep the different bins for the segregation of the waste generated at their place. Then Okay, then duties and responsible for local authorities, framework and outreach. Uh, there are some different rules which you have to read. Then there are some rules for the sanitary landfills, standard for treated leachate content produced during the landfills, then standard for incineration. There is some case study for Hyderabad, Ahmedabad, then smart city indoor. One second. Okay, that you can read. Okay, so now we will go for some question answers based on this week lectures. Okay, so first question is, which of the following activities most preferred in the ISWM hierarchy? So we have talked about the ISWM hierarchy. So the first activity which should be done is they should reduce the waste generation at the source itself, and they should try to reuse it if they can reuse it. Okay, that will create that will help in the reduction of the solid waste generated. Okay, and that will help the municipal solid waste municipal corporation also for the proper disposal of the solid waste. Then according to the ISWM hierarchy, after source reduction and reuse, second most preferred one is recycling. Uh, so this will be second one. Then waste to energy will be third one, and fourth one will be landfill. So the most preferred ISWM hierarchy is source reduction and reuse of the solid waste generated in any type of community, or we can say household or institutions. Okay. Then second one, which sweeper has lower energy demand in street sweepings? Vacuum sweeper, mechanical broom sweeper, regenerative sweeper, or none of these? So if we are going to talk about the energy demand in these different types of sweepers, so the lowest energy demand will be for mechanical broom sweeper. Then this one will be the second one, and regenerative sweeper, that will be the third one. Okay. Then engineering division of the local authority is responsible for removing slit from surface drains or stone water drains deeper than. So according to rule, they can remove the slit according to rules, the municipal workers, they can clean, they can remove the slit from surface drains, which is up to 60 centimeter. After 60 centimeter, the engineering division of the local authority should be responsible for the removing of slit, okay, from drains or stormwater drains uh, deeper than 60 centimeters. Okay. Then what is the permissible time for collected silt to be on the open road? So according to rule, the silt on the open road should be collected within 4 hours for the proper disposal of that silt. Okay. Then fifth one, it is the duty of which ministry to set up labs to test the quality of compost produced by local authorities. Ministry of Urban Development, no, that ministry is generally responsible for the disposal of the construction and demolition waste. Then Ministry of Chemicals and Fertilizers, no, that is responsible for the generation of, like we can say, uh, the proper disposal of the leachate materials produced during the landfills, or we can say that is responsible for making the rules for the proper disposal of the waste generated in the waste to energy plant. Okay. Then third one is Ministry of Agriculture, Government of India. Yes, this is responsible for the setup of the labs to which can test the quality of the compost material produced by the local authorities by using the municipal solid waste. Okay. Then Ministry of New and Renewable Energy Resources, that is responsible for the for making the rules, or we can say for making the lab setups for waste to energy conversion. Then next question, which of these e-waste stream is covered under Schedule 1 of the E-Waste Management Rule 2016? So in the E-Waste Management Rule 2016, the dry cell batteries were not covered under the e-waste management rules, neither the lithium ion batteries and mercury were also not considered during the e-waste management rule 2016. So plastic was the only one from the e-waste stream which was covered under the uh, e-waste management rule 2016. Then the maximum allowable value of suspended solids in treated leachate while disposing in land is, that should be 100 milligram per liter, 600 milligram per liter, 200 milligram per gram, or 200 milligram per liter. So third one cannot be possible because that is 200 milligram per gram, but we are talking about the suspended solids in liquid. Okay, so the unit should be milligram per liter only. Okay, so the allowable limit for this value of suspended solid in treated leachate according to MSW rule 2016 is 200 milligram per liter. Okay. Then what is the acceptable level of suspended particulate matter in ambient air at the processing or recycling site? So according to MSW rule 2016, it should be around 500 microgram per centimeter cube for 24 hours time period. Okay, that is the acceptable level of suspended particulate matter in ambient air at any processing or recycling site. Then according to the manual of solid waste management, dry waste should be segregated in which color coded bin? So according to the solid waste management rule, the dry waste should be segregated in blue bin. blue color coded bin. Green bin is for wet waste. Then yellow bin is for your hazardous biomedical waste, and this white bin is generally used for the construction and demolition type of waste. Okay, or we can use it for some other type of waste also. So these are the color codings for according to the municipal solid waste management rules. Okay, then list the objectives that are not framed according to e-waste management rules 2016, to regulate the generation, to reuse the e-waste, to regulate the transportation of the municipal solid waste, or to regulate the disposal of e-waste. So according to the e-waste management rule 2016, they have regulated the generation of the e-waste. Then they have also regulated the transportation of the e-waste. Then they are also regulating the proper disposal of this e-waste. But they have not talked about the reuse of the e-waste material. Okay, so that is not to reuse the e-waste. It is not the objectives which were framed during the framing of e-waste management rules 2016. Okay, okay, so this is for today. So if you want to ask any question, you can ask, or we can close this meeting. Anyone want to ask something? Any doubt? Okay, so this is for today. So we will close this meeting, and we will meet again next Sunday at 4 to 6 p.m. Okay. 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 Thank you, guys.